started. So, do the series converge? Let's go ahead and it's tempting to do the ratio test. So I think what we're gonna do is we're gonna do both. We're gonna do alternating series tests because these are all alternating series questions, and then the ratio test. So let's go ahead here. I want to make sure I have my notes handy, so because I don't want to mess up the notation. There you go. Alright, so let's go. First, the alternating series. We take the non-alternating part and we address if the limit of the non-alternating part goes to whatever value. We have n plus 1 over n. That's going to 1 because it's a balanced equation, and that does not equal 0, so therefore it diverges via the divergence test. Let me do another color for the ratio. Oh, here, I need to fix that typo. 4.6. Then for the ratio, what you do is you take the first term. No, I'm sorry, you take m plus the first term, m plus 1 of the term. Sorry, I said that real wrong. Take the m plus 1 term. -1, n plus 2, n plus 2 over n plus 1. And then of this one, you get n over -1, n plus 1 over n plus 1. And then from here, you go ahead and you can cancel out the negatives, and you're left with just one negative on the top, but it's -1, so it kind of doesn't matter. -1. From these guys, you can't really cancel anything out. So you're kind of just left with this expression. I'm going to already do it. It's n squared plus 2n. And then this expression, which is just n squared plus 2n plus 1. Okay? So in that case, take the absolute value. You have n squared plus 2n over n squared plus 2n plus 1, which is a balanced equation, so that means the limit is 1. And then via the ratio test, you say that it's inconclusive. So, inconclusive via the ratio test, which doesn't necessarily contradict the diverges, it's just this one tells you directly it diverges. This one's just inconclusive. Okay. All right. Let's see. Okay. Next we have this one. Let's solve this the old-fashioned way. Limit as n goes to infinity of 1 over n, and that does indeed equal 0. Okay. Now we have to check the second part, which is does it steadily decrease? Well, we can see here that it does steadily decrease. Just because I want to practice it again, I'm going to do f of n prime, which is 1 over n prime, which is -1 over n squared, which definitely will always be less than 0. We do the derivative of this because that tells us our slope. So it's telling us if it's decreasing, increasing, or stagnant. So I'm doing the derivative because I want to see, well, like for when is this a negative slope? And technically, it's always going to be a negative slope. It's not always going to be, oh, what's the phrasing I'm looking for? It's not always going to be like a super steep or whatever, but because of this negative, then we know that no matter where you look, reading at any point left to right, it's going to be decreasing. Let me go ahead and just show you just in case. So see from here, it's this one. So we go from, any point going from right to left, we see that the value decreases. The only time it doesn't is the discontinuity part, which is at 0. But either way, we only care when n is 1 or greater. So in reality, we could even write, I forget how to do it here. I want to say it's comma x is greater than equal to 1. Forget if it's comma or semicolon for Desmos. Let me see real quick. If I can do it real quick, I just want to show it. I want to say it's semicolon, but I can't access it here, funny enough. Well, either way, you can see that from when it's 1 and above, it's going to be negative. Okay. Let's see. Next, we have. Oh, right. And then doing the ratio test. My bad, my bad. Oh, wait. I'm going too fast. So this converges via the alternating series test. Let me just make sure I mess up any lingo. No, we're good. Um, okay. Do the ratio. Let's see. Limit as n goes to infinity of the n plus 1 version of this. So -1 n plus 2 over n plus. Oh, that's funny. I think it's the same issue that we're going to have over here. Well, I guess it's good that we practice it anyway. N over, yeah, -1 n plus 1. That's going to cancel out to be a -1 on the top. And then we have n over n plus 1, which you can see us skipping the steps and getting inconclusive again. Okay, let's go here. First, I'm going to check the limit as the non alternating part. So limit is a 0 of the non-alternating part. We have n over n squared plus 4. And that definitely goes to 0. But then we want to check if this value is always decreasing. I'm going to go ahead and check that. I could do derivative. I'm down for derivative. Let's do f of n. Let's see, we have n over n squared plus 4. The derivative of the top is 1. So times n squared plus 4. Then minus the derivative of the bottom, which is just 2n, and then times the top, which is just makes that n squared over n squared. And you'll see here that we can just simplify this to be -2 n squared. No, wait, sorry, not -2. It's going to be negative n squared. Oh, am I out? No way. Oh, I just the wrong side. Okay. Negative n squared plus 4 over n squared. All these values are actually no, because the top has the potential, because that's always going to be positive. but we care about when this top part will be negative because the whole expression has the negative. Or it's not a negative of the whole expression, it just includes a negative. So we care about when this is less than 0, which we can just do 4 is less than n squared, square root to get 2 is less than n. So that means at n is equal to 1, it's not decreasing. And n is equal to 2, it's not decreasing. So it's only going to decrease when n is greater than 2. So that tells me 3 and above because we're doing a series. So we're using the whole numbers. 3 and above, which doesn't mean it always decreases, but this is the special case I was telling you about when I was telling you that this decreases eventually. Let me just go ahead and I kind of want to just confirm that softly just to see if at those values it will not decrease. I'm pretty sure the math checks out, but I guess because I already had it out, it's kind of a nice just visual trick. Let's see. So, uh, let's do 5. Let's do from -1 to 5, and then from -5 to 5. Okay, so maybe do 1. Okay, so we see here that at 1, it's definitely on an incline, right? And then at 2, maybe it's not at an incline, but definitely just has this sort of like plateau. And then at 3, we notice that is decreasing. So this is that logic I was telling you about where it decreases eventually. In fact, if we want to know the slope at, n is 1, n is 2, we could get that answer when, here, I'm going to do this on the side because it technically doesn't matter. It's just something that we're like double downing the logic in. F prime. I don't know why I did that. F prime of 1, what is that equal to? It's -1 plus 4 over 1. That's going to be, what, 3? And that's a positive slope. F prime of 2 is going to be -4 plus 4 over 4. So that's going to be 0. So I was right about it being stagnant. But we can see if you could check for 3, 4, 5 all the way, it's going to decrease eventually. So with the caveat of the decreases eventually logic, because really it is going to decrease eventually. With those first two terms, that's not that crazy of a logic. With the first two terms being just stagnant and then it starts decreasing, it's almost like we just gave like a constant to our sum. So really, we can still use, or we can still claim it converges via the alternating series test. Okay. Now, do I want to do the ratio test? Because I said it wasn't intended to be 4.6, but I was like, well, we could try. But my only thing is that I don't want to just keep getting inconclusive because that's not the whole point of the ratio test. Um, but let's just try them. Let's see, we got limit. This thing goes to infinity of this whole expression, -1, n plus 2, n plus 1 over n plus 1 squared plus 4 times n. Um, the -1, n plus 1, and then on the top is n squared plus 4. So from here, you are going to get that the limit is equal to 1 because once you expand these polynomials, or wait, you'll get power 3, you'll definitely get power 3, yeah, so it'll be balanced and the coefficients leading will be 1. So reality, this is 1, which is inconclusive. Okay. Um, Give me a quick moment. I want to gloss over something just really, really quick. Okay. All right. Let's go ahead and do the last one. And I don't want to worry about doing. I'm gonna skip the ratio test for this one. And I'll let your homework be the purpose of the ratio test. Uh, we have the alternating series test first by checking if the non-alternating part is limit, and the limit of this is 4n 5n plus 3. That's balanced. So it's 4 over 5. And that does not equal 1. I mean, does not equal 0. So via divergence test, sum is divergent. All right, that's going to wrap up the worksheet video. Let me know if you guys have any questions, and I'll see you on the next one. Bye bye.